Number 7. A copper bus bar is built of two copper bars 50 feet long, each having a cross-section of 5 by 0.25 inch. The two bars are spaced 0.5 inch in between adjacent surfaces, and they are connected in parallel. The resistivity of the copper is 0.758 micro-ohm-in at the operating temperature. Determine for A, the resistance of bus bar, B, total weight if an inch of cube of copper is 0.3214 pounds, 0.3214 pounds. Okay, so let's start with summarizing our given. And our given is the following data. So we have a weight of 5 by 0.25 inch, the thickness of the bus bar, and the length of the bus bar is 50 feet with the resistivity of 0.58 micro-ohm-in, and we are tasked to determine the resistance of the bus bar. Okay, so for A, let's recall the formula right away. So for A, we are tasked to determine the resistance. So your resistance is equal to resistivity length all over the cross-sectional area. So we substitute the value right away. That is 0.758 micro-ohm-in with a length of 50 feet. Okay, then we do minor conversion since our resistivity is in inch, so we need to convert inch to feet. In every feet there are 12 inches. That is for our length all over the cross-sectional area. For our cross-sectional area, we need to determine the cross-sectional area of our bus bar, which is equal to this portion. That is your thickness and weight. Means that your cross-sectional area here is equal to your width times your thickness. So that is your cross-sectional area. Okay, so we substitute the value, that is 5 inch by 0.25 inch. Okay, so we do the cancellation of units. So our units here, 50 feet, will be converted to inch. Then our unit here will become micro-ohm, inch times inch is square inch. At our denominator side, we have square inch, so our inch will be cancelled out and our square inch will be cancelled out. So the remaining unit is micro-ohms. Solving for R, we have 363.84 micro-ohms. So that is your answer for A. So that is the resistance of our copper bus bar. And for B, we are tasked to determine the total weight if the weight of an inch cube of copper is 0.3214. That statement, for B, we are asked to determine the value of our weight, the total weight. That is our total weight. Okay, if we recall the formula for our weight density, our weight density is equal to weight over the volume. Our weight density is already given. Our D is already given, that is equal to your 0.3214 pounds per cubic inch. So, since our unknown is the total weight, therefore, our total weight is equal to your weight density times volume. But wait, we need also to determine the volume. The volume, if we recall the formula for our resistance, our R is equal to the resistivity length squared over the volume. Do we have the value for R? Yes, we solved it. We solved it already in a problem. We have the value of resistivity? Yes. The length? Yes. Therefore, we can determine our volume. Okay. So let's start solving our volume first. So our volume, therefore, our volume is equal to the resistivity square of length all over the resistance. So we have the value of our resistivity, 0.758 micro-ohm inch and 50 feet. 50 feet. So, volume muna tayo. So, volume, that is resistivity is square of length all over the resistance. So, do we have the resistivity? Yes, it's already given. 0.758 micro-ohm inch. Our length is 50 feet. Our unit is in, so we need to do conversion, the same conversion, that is 12 inch. Oops, the unit is squared, our length squared all over the resistance. We already solved it. So the resistance is 363.84 micro ohm. Okay, so we do the cancellation of units. So in feet, yes, cancelled out. The remaining unit here is in square inch. Here, micro-ohms, cancelled out. So the remaining unit at the numerator is your inch times square inch, that is cubic inch. Okay, so solving for your volume is equal to, that is 750 cubic inch. Okay, so we have the value of our volume. Now, we can solve our weight density. Okay, so solving for your weight density, that is equal to the total weight equal to weight density times the volume. So our weight density is given in the statement, that is 0.3214 pounds per cubic inch. So what is the value of our volume? That is 750 cubic inch. Okay, so we cancel out common units. The cubic inch will be cancelled out. The cubic inch will be cancelled out. The remaining units is in pounds. Okay, so finally, our total weight is equal to, the total weight is equal to 241.05 unit pounds. Okay, so that is the value of our weight.